thanks everyone for coming. So I guess this is the second session of the how to make an app. Richard did one last week about an iOS app. So this week I'm doing how to do an Android app. Yeah, so what we'll be making today is the counterpart to what we built last week, which is a cats app. What we are going to do is we're going to go to Instagram and you're going to grab some pictures of cats. Yep. So, and then we're going to put the caption below that. So very simple. We're just going to have a long list of cat pictures that are coming from Instagram. And yeah, we're going to build it on Android. Okay, so I guess starting off, so to build an Android app, you need a few things. And first thing we need is Android Studio. So it used to be done in Eclipse, and now it's actually done on Android Studio, which is like a variant of IntelliJ. So you can go to Google's Android website and download that, and it comes with the SDK and all the tools that you require to get an Android app going. Yes, it is free. Yeah. So I think it's much like IntelliJ's Community Edition. Yeah. Yeah. So and then it also comes with an emulator that you can run your apps on. It's actually quite slow. So I suggest you look into this thing called Genymotion. They let you run similar kind of virtualized environment for Android, and it's a lot faster. But for this demo, we'll just use what comes with the Android Studio, so you get good familiarity. Yeah, so I guess to start off, we'll just go ahead and create a project, and then I'll explain some basic concepts, as Gradle goes through and builds some of the stuff. So creating a new project's pretty easy. So I'm sorry if it's too small. I'll enlarge it once it goes to code. So we're gonna make let's call it Instacats. Okay, so we'll put it there. So the first decision you'll have to make when you make an Android app is this vast number of versions that are available for Android. You can see that all the API numbers, which refers to which version of Android. My recommendation is build for above API 14, which is ice cream sandwich. Before that, there was a lot of transition within Google and the APIs that come with Android. So phones kind of gained popularity in the version 2, and then Google decided to do a tablet-specific version of Android in 3, and then in 4 they kind of combined everything they did into one big API. So 4 is a really good starting point, and I think really there's a large number of people with devices above 4.0. So that's what we're going to do. We're not going to do any of the TV or watches. So similarly, you can pick a number of things. We're just going to pick the one with the blank activity. I think that's good enough for today. And I'll explain to you what an activity is in a short while.
Are handset manufacturers still customizing Android and making it difficult? Or
yes, they are, but Google has a lot of the services up on what is called the Google Play services.
Yeah.
So, and they make them sign a contract, and they try to control some of the distribution based on that. Yeah. Okay, so let's get this going. So Android's just gonna go through and build us a bunch of things. And what I might do is I might add a couple of libraries that we will be using today, so we can talk about some stuff while it goes through and download all of that. All right, so So Android SDK comes with 4 main parts for your app. So your app can comprise of these 4 main parts when you build an Android application. The most frequently used one is called an activity. An activity is like a view controller where it can present a view to the phone or the tablet. It's basically what your UI will be contained in. But the other 3 are not so similar to what you might be familiar with iOS or other mobile platforms. So let's take an example of a music application. Say you're building a music app. Maybe you're building an iTunes app. So the UI will be made in activities. So each page will be an activity. And the services don't have UIs, but they can perform long-running tasks over time. So in our music app, what will happen is the music will be played through the service. So even if your UI is killed by the OS for memory issues or whatever, your music will continue playing in the background. And the way it'll work is the user interface will connect to the service and constantly find out its status. And the other two are very infrequently used. One's called a content provider. So they're like little database beacons that you can have in your app. For example, if you want to let other apps connect to your music app and get the music data out, you can have a content provider and provide some documentation online so other people can have access to it. A really good example of how it's being used right now is if you want to look at the user's contacts, you have to connect to a content provider provided by the OS. A broadcast receiver is an interesting way to catch events broadcasted by the system usually. So when the screen goes off or the phone's running low on battery, the OS will emit events, and then a broadcast receiver can catch that, and you can do something about it in your app. And how all of these kind of come together is through this mechanism called intents. So in Android, when you say you have a list of emails, and then you go and look at one email. So these are 2 different views. So these will be 2 different activities. And the way you tell the next activity what to draw is through a little event called an intent. So when you press on an email, it'll fire an intent saying, hey, this email with this ID is picked. And that will actually flow through the Android OS, and it'll then wake up the next activity and say, hey, you need to open this email with this ID. What's interesting there is that intents let you go outside your app. So you can say, hey, I need a photo editing app to edit my photo, and you can pass your photo. And then Android OS will look at your apps list and see which apps can edit a photo and give it back. And if you own an Android phone, you would have seen that, like if you have like multiple photo apps installed, the OS will ask you, which one would you like to edit the photo with? Yeah, so that happens through an intent. So Android apps are a little different from iPhone apps, where it has this it used to have a hardware back button, now it's drawn by the software. And it's quite interesting because if you think that your app is A, and you open other activities from other apps, in your workflow. For example, say you go to the web browser to look at something, and then that comes back to your app, and then you go to a photo editing app. Your back button will continue to function in the right order. So it might be a little jarring at first when you buy an Android phone, or you were in the browser at some point in time, you hit back and you went back to your app, and so it kind of goes in the logical order that all the activities are aligned in. And Android will maintain the stack for your application properly. And sometimes it will wake up other apps and create new instances and put to this stack as required. And so activities themselves go through, a certain life cycle. Don't know if I can make this slightly bigger. Not really. So it's not too important to know all of this at the start, but it's good to know that there is this workflow involved, and at each of these places, like when you hit on pause, when is it on pause, when is it on stop, when is it on destroy, like different actions the user does will cause those methods to fire. And then you can do things like, if you have a stopwatch app, you can stop updating the clock on the UI when it goes to on pause because something else has come over your activity. So that's ways you can save the user's battery by not constantly updating the UI. So yeah, so I think that's a good introduction to kind of how everything's kind of laid out in the system. So let's head to the code and look at how we can get this app going. All right. Okay, so this is the project that Android Studio has created us. So there's three main parts to the project. It always comes with this file called Android manifest, and that tells the operating system, what activities you have in your application, what permissions your app requires when you install it on the system, and all of that kind of information goes in here. And also what intents from other apps your app will respond to. You can see here that the Android's launcher can launch my app. You have to have that, otherwise there's no way of opening your app. And the other two are pretty similar, pretty easy. We have the Java source where you'll be writing all your code, and then you have your resource folders where you can have images. For example, this is the app icon that we've got, and then you got a bunch of XML files, which is the way Android does layouts. Yeah, so you can see that it's actually gone through and created a cats activity for us. So let's quickly try running the app and see what we'll get. So here I'm just saying, okay, we're gonna run in the emulator.
We're not doing dogs here.
No.
That's winning again.
So okay, so we have a Hello World application, just a name and a blank page. So what happens there is when the app gets created, the OS will look in there and say, okay, that's my main application, so I'm going to wake up that activity. And basically, when the activity is created, the activity says, okay, my content is contained in this XML file. And if you go to that, you can see the app is there. It just says Hello World, and it's just the text view inside that. And this is how the XML looks. It's a relative layout and a text view. So what's a relative layout? So in Android, there's views, and then there is view groups. So groups are ways to contain more than one child inside that view. Now, from the get-go, Android was always made to be responsive. So these view groups are really important because you can have linear layouts which stack items, horizontally or vertically, and relative layouts basically lay their children relative to each other. So you can say, oh, I want this one below this one on the left of that one, yeah, that sort of things. There's a number of different layouts you can get, and you can see all of them down this way. Frame layouts can only have one thing, table layouts, grids, and relative. But you'll mostly be using the relative layout or the linear layout. That's the most logical way of putting items together. Okay, so what we first want to do is so if you look at our app, earlier we had a list of items in there. So what we want to do is we want to go and add a list in there and start populating some data. So what I'm going to do is I'm going to look for the list view, and then I'm just going to drag it in here. Yep. And so that this is what happens when you drag it in. Basically, it just adds another XML thing. And you can actually go in and edit stuff in here, no problems at all. In fact, initially when Android was made, you had to go and edit the XMLs. Yeah, so that's pretty straightforward. Okay. Now the next thing we need to do is we need to go and we need to populate stuff in the list view. So how do we do that? For us to do that, we need a reference to the list view. So what we're going to do here is we will create a reference here. Most of you might have some experience with web programming, so Android is very similar in that sense. In JavaScript, when you work with the DOM, you got to find by ID. So same here, you tell the activity, I want to find it by an ID. Now where is the ID? So if you go here and look at your XML, it's said it's the list view there. So let's give it a nicer ID there. Okay.
It has to be unique, presumably.
So it has to be unique in that context. So if it is in the same view, it has to be unique. Otherwise, there's going to be a conflict. But say if it is in different activities, you can have the same ID, and it will not conflict because the activity can maintain its current context and what IDs belong to that. And you can see Android's already given us that. So we'll say our photos list view belong is, so we've grabbed the reference to that. Okay, so the next thing we want to do is obviously get some data in. So today we'll be working with the Instagram API. So that's the API we're going to work with. And Instagram's going to send us a bunch of data, with a bunch of cat images in it. I thought for this presentation, it might be a little too much to do all of the networking code. So what I'm going to do is I'm going to paste in some of the networking, and then we'll quickly run through, what that is. Okay, so what do we have here? So we'll grab all of that in here, and okay, so here I'm going to use a library called Retrofit. So it's a library from Square. It's basically an annotations-based networking library. So all you really have to do is say what kind of HTTP method you're connecting to and what's the URL, and then that kind of does the whole thing and give you a way to interpret that data that's coming back. So here what I've done is, okay. So here you can see we have the Instagram token here that allows us to connect, and what I've done is I've gone through and created a new method which has the tags that we can look for the cat pictures. Yeah, and then what we do is we create a JSON JSON class where we can interpret the JSON that's coming back into data objects. And all of that is kind of contained in this REST adapter under this Instagram service. I just mostly followed the retrofit guidelines, and when you go and work on it, you can do that as well. I recommend you use another library because the Java libraries that come with are really complex, and you have to read line by line, and it's very primitive. Yeah. Okay, so I've created two data objects. One's called a photos list, which is just going to have a list of photos, and we're going to have a photo model which is going to contain the photo URL and the caption that we are looking for. And I've also created a So I've also created a serializer which actually gets the JSON element coming from the server. And when you get that, you basically go through the data. So if you look at that, you can see that we have data there, which is an array of items. So I'm basically going through each of them and creating a new photo object. So when our app starts, it can do a network call, get a bunch of photos, and it will be contained in the photos list. Okay, so let's go ahead and get some photos going. We might put it in another method. Okay, so we get our Instagram service, and then we get photos with hashtag, and we are looking for cat pictures. And this method is going to give us a list of photos. What we might do is we might save it here. Okay, so let's run our app and try to get that data back. Okay, so now the app's crashed. Okay, so let's have a look at the error message that we got. Okay, so yeah, I did. Yeah. Okay, so we have this exception called network on main thread exception. So when you're developing, Android will actively check that whether you're networking on the main thread or not. And if you are, it'll kill your app, just to let you know that you shouldn't be doing it. Yeah. Okay, so let's put that in a background thread. And how do we do that? In Android, you can separate out a task to run in the background through this class called an async task. So asynchronous tasks get put in a queue, and they run sequentially one after the other. And the way to create one is it takes a bunch of params. Here we are not taking any params. We are not really reporting on the result. You can report on progress as you go along in a async task, but it is going to give us back a photos list. Okay, so we'll create a new async task, and might get this out of the way. Okay, so it's given us this method that we can do some background things. So what we're going to do is we're going to move this up to that, and we're going to return the result that's coming out of that. Now, of course, we have to do something about it. So it gives us all these hooks that you can deal with. What happens if it's cancelled? What happens before the task runs? And what happens after the task runs? So you can see it already passed in the photos list from the previous one, from the background method. So what we're going to do is we're going to assign our photos list here. And this can be guaranteed to be on the main thread back again. So it does that work in the background thread, and it comes back into this. Okay, and then we always need to run the task. Okay, so let's run our app and see what happens now. Okay, no, that's just Okay, it looks like it. Let's run it again. Okay, looks like it crashed again. So let's go and read the error again. Okay, this time it's a security exception. And it's saying that we don't have permissions to go to the internet. So when you install an Android app, you will be asked for permissions to even connect to the internet. So what we have to do is, remember I talked about the manifest file, we have to go to the manifest file and say, oh, we need internet access to run this app. Okay, so we're going to grab a couple of those permissions and I go here and say, tell the app, okay, we need to access the internet, and also we need the app to know the network state so it can know when things get disconnected. Okay. Okay, let's run the app again and see what happens this time. Oh. Okay, this time it didn't crash, which is good. And you can see that actually our Instagram app returned a whole bunch of data. So awesome, we have some data. Now how do we put this in the list that we have? If you didn't turn up last week when Richard was explaining how lists work, in mobile devices, it's really expensive to create thousands of rows of data. So imagine your contact list. You may be extremely popular and have thousands of contacts. So what happens in a mobile device is it'll only draw the whatever number of rows that the device is showing right now. And as you're scrolling the list, when a row goes out of view, it puts it in a recycle bin. And the next time it needs to create another row because the user is still scrolling, it's going to take that row out of the bin and then it's going to give it to you, and then we're gonna populate the new data into that same row. So basically it's this shuffling happening over and over and over. So if you find that you are using an app and then it's scrolling really badly, it's because they are doing a lot of work while you're trying to scroll, so performance is bad. And so the way the list view knows what to draw is we need a template for each row. So what we might do is we might go and draw a new template. We will create a new resource file to say, okay, we need a row template to display a photo. Okay, so what we are going to do is we are going to look for image view. Where are you? Yeah. So we're gonna add the image view, and then we also need some text under it. So we're gonna add the text there as well. So just to show you how these layouts kind of arrange into one another. So you can see here these special keywords. So each layout, each item can have a width and a height, which is pretty straightforward. And they both say, okay, I want to match my parent. And in this case, whatever it's drawing, it wants to be in that size. And we have an image view, and it's saying, okay, wrap the content, which means it'll expand as far as it needs to, both width and height, to show the content it has. Now, if you want to have something that's more defined, we can put the pixel number in there. So usually we work with device independent pixels. That's what DP stands for, because there's devices with a lot of different sizes and you don't want to go with pixels, then things will look terrible. You always have to think about all the crazy big Android phones and the tiny ones that are available on the market when you're creating layouts. So we'll say the height will be 320, but the width we still want it to match its parent. So you can see that's actually created us a nice big image there. That's where our content's going to go in. So for the text view, so this says it's vertically positioned, so the text view is going to be under the image view. And again, we are going to say match the parent for the width. And we're going to wrap the content, so which means it'll expand as far as it needs to. And this is pretty much like your CSS or styles that you are working with. So you can go in and say, okay, I want to add your padding of 20 pixels, and then that's going to get padded out. And you can do things like margins and alignments and all of that, and then you can separate them out to a different styles file if you want to as well.
Does it have like not just DP, but does it have like M's or stuff like that?
Yes, it does. So it has points, M's, DPs, pixels for you to work with.
Does that get crazy across different devices, or is it pretty much consistent?
So DP is the most consistent one to use for layout items, but for fonts you want to use points or M's. Yeah, so that's kind of the two that I generally work with. Yeah. And I'll show you in a while what you want to do when the device's sizes grow bigger as well. So we have a what we might do is we might give them nice IDs so we can find them later. Okay. Okay, so we have a nice layout for each of our row templates. So now all we have to do is go and populate that. So
You're talking about the gravity at any stage there?
the gravity. Okay. So wrong one. Okay, so the gravity refers to, so when you have this layout keyword, it means that property really tells its parent how to lay it out. Okay, so
This is where the relativeness comes in.
correct, yeah. So now it's saying the layout gravity. Gravity is alignment in Android. It's probably good to know that now. It confused me for a while. So it says that, okay, center horizontally the item, right? So because if you had like a wrap item and the image was small, then the layout doesn't know whether to put it in the left or the right or the center. But
I would think it'd be like how it behaves when you scroll or something like that.
yeah, it really has nothing to do with that. So to make things more complicated.
Or is it headed, or-
You're gonna fall quickly. Look out.
So for example, if you want to make the text align to the center, it's called gravity, and then you want to say, I don't know, see. I think it's not. I don't know why it's called gravity.
Why did you call it gravity?
I will give someone at Google a call and find out. Okay, so back to our activity. So the list view needs a template, and the way that works is the list view always goes with a pairing, which is called an adapter. So adapter is the thing that always gives it a view. And so what we need to do is we have to go ahead and create a class that the list view can use. So what we might do is we might create a new class, and we'll say it's the cats adapter, and we have a nice class we can extend out of called the base adapter. It gives us a lot of the functionality that we need. Okay, so it wants us to implement 4 methods, and this, if you have done iOS programming, this is a data source object. It basically tells you how many rows we have, and for each row, give me the system will call you okay, I need the row for that, I need the row for position 2, 3, 4, 5, and then you create it on the fly and give it back. And then it might hand in a view that's already there, so it'll dequeue a row for you if it's in the recycle bin, and it will give it to you to repopulate. I might make this a little bit easier to understand. So this is the position passed in. Okay. So we'll write a constructor, and I'll explain to you why we need a context object in a little while. And we need a way to set the photos. So again, we'll keep a list of photos here. So we'll initialize it there. We'll just say we'll find pass in photos list. And I have a nice function in there that gives us an array list back of all the photos inside that. Okay, so get count. Basically, it's just asking what's the number of photos you have. So we just ask for its size. So these two methods are really just convenience methods for you. It's really not very important in our example, but it's going to make us implement them anyway. So we're just going to give them what they want, which is to return the item for that position. Same here. What we might do is we might get item of that position and then return the hash code. It's just a unique identifier that you can get for that object. Okay, so this is the fun part. So here we go. Okay, if our view is null, that means there's nothing in the recycle bin for us to pick up from. So we need to create a new view. Let's spell that properly. So remember how we had a row from the XML? So now we have to inflate that row into an actual view on the fly. So Android gives us this system service called the layout inflator. Yep. It's and then we have to pass in a context for it, so it knows the correct resource IDs to load from. So we're going to inflate the layout that we created. And then the container. So now we have a convert view, which is created from the resource. Okay, so now in there we have to populate the things we put in there. So, okay, first let's grab a we have a reference to the photo that we are working with, and now we know we had a text view, which was the caption. So we'll say find by ID again. And so same deal there. So we're looking for the caption ID. And then what we're going to say is, okay, caption. So we're going to set the text inside that to our photo.caption. So we're going to repeat this process again. photo. Ooh. Okay, now in mobile apps, it's for you to download a photo from the network and cache that, and also keep it not so memory intensive is a fairly big task. So to make things easier, I'm going to use another library from Square. It's called Picasso. So it caches the images for us, it downloads them in the background, and do all of the heavy lifting for us, and it'll eventually give us a nice image on our image view. So I'm just going to use that. It's a lot easier than actually rolling out your own networking and everything for that.
Because currently all you've got is a JSON URL. Is that
Correct. That's right.
Yeah.
So if you look at here, we basically have that URL that Instagram sends down. So we have to go and download that now. Okay, so we don't want that URL, we want our URL. So we have photo URL that we might download that. And that's it. So we populated the things and we are returning that view back to the system, and the system will help us draw that. So back to our activity, we have to do a couple more things, which is now we need to create the adapter here and join it to the list view. So we'll say new adapter, and then the context it requires is the activity. Activity knows what context it's running on. So we'll say photos ListView.set adapter to our adapter. And then what the ListView is going to do is when it initializes, it's going to start shooting events at the adapter and say, hey, give me the view, give me the view. How many stuff you have? Okay. And then in here, what we want to do is we want to tell our adapter, hey, the photos have changed. You should update yourself. Okay, so let's see if this works. So it looks like we still don't have any items. So what's happening there is that whenever your data changes, on iOS you have to call reload table. Same way you have to tell that the data needs, that the list needs to be notified that, hey, my data's changed. So let's run that again. Okay, so we have some data. And then we have some pictures.
That's not a stretch.
Yeah.
So if you come from like an iOS background, you'll be used to measuring out how big your cells are. Android measures them out for you. So this label is really long. We might do one more thing here just to make things a little bit better. Okay, so all I've done is change the scale type, so the image is going to stretch the image out to the full width and height of the image view. So I got a couple of minutes, so I mean that's the entire app, but I would like to show you guys a couple of interesting things about Android since I got a little bit of time. See how these drawable folders have a suffix under it. So that's an interesting construct in Android. It's a bit like a CSS size class. You know how you have like max width, 728, 768, then it'll do a different CSS style sheet to another one. So that's kind of how this works. So let's quickly have a look at the resource directories. So resource directories can have all of these values that are attached to it at the back. So for example, I can have a layout that's very specific to large devices. And what Android's going to do is it's going to look at the most relevant, contextually most relevant folder first, and then it's going to work its way back up the hierarchy. So for example, in our list view, if you needed a grid view for tablets, so you'll go and add a new layout just for the activity into a folder, into a bucket with layout large, and that's going to load that instead. So that's kind of how Android achieves responsiveness. You can actually go and customize it as much as you want. So you can have screen density. You can even have a layout just for nighttime. I've never really seen some of this stuff used. If you have different language restrictions, like for example, if you're doing Arabic and they're going right to left, and you want to have a different layout for that, you can do all of that as well. Yeah, so that's kind of how Android works. So even the internationalization works the same way. So you can have value folder with language suffix. So you can have DE for German, and then it'll go and load that strings file instead of the main one. And that's how you can do things like padding. So you can actually have dimensions that change between different sizes of screen. So you can kind of lay them out in a very dynamic way. So it's a lot like CSS, basically.
Very well.